Dear students, here we are in the video for the language course. Now we will start the Wilcoxon sign rank test. We already began with Wilcoxon tests that consider different magnitudes by using ranks. The two tests of Wilcoxon tests are the Wilcoxon rank sum test and Wilcoxon sign rank test. Wilcoxon sum rank test used in the case of independent samples. If we have two independent samples, so we use the first case of the Wilcoxon test, which is the Wilcoxon rank sum test. And we already covered this test and take an example and exercise on it in the previous lectures. Now we will move to the Wilcoxon sign rank test. We use this test when the samples are dependent because there's something which is common in between the samples, like after and before tests. So when the samples are dependent, they would be in before and after tests, we will using the same subject. The Wilcoxon rank test can be used in a place of t-test when the samples are dependent and the test doesn't require a condition of normality. Of course, as we mentioned before many times, we first use the parametric testing, which is t-test, z-test, and proportional tests if the condition of normality is applied. But if we haven't the condition of normality, so we use the non-parametric tests, and we already covered another ways and another tests that can be used in the case of non-normality. Here we are in a case for the Wilcoxon test that there is a difference in magnitude by using ranks, and the two samples are dependent. Please use your book and appendix in C and table C in the appendix to use the critical values for these tests. The procedure for the test is shown in the following example, but you should have the values from table C in the appendix in your book. In a large dependent store, the owner wishes to see whether the number of shoplifting indicates per day will change if the number of uniformed security officers is doubled. So we have a case that very large department and the owner wants to know if the difference before and after shifting incidents. So a sample of 7 days before security is increased and 7 days after the increase show the number in the following table. So we have 7 days from Monday up to Sunday and numbers of shopping left in sides before and after. Now the question is there enough evidence to support the claim at alpha equal to 0.05? What? That is, there is a difference in the number of shoplifting incidents before and after the increase in security. So we have the same steps. The first step, state the hypothesis and identify the claim. The first step, we have H node, which is a null hypothesis, and H1, which is the alternative hypothesis. The null hypothesis that is no difference in the number of shoplifting before and after increase in security. So we note that the H node always represents the number where there is an equality, and H1 is always show the number and which is the another for the claim. So H1 here, there is a difference in the number of shoplifting before and after the increase in security. The second step, find the critical value from the table C in the appendix. Table C will be that we have columns and rows. The rows here for the sample size n, and the columns for alpha, which is begin with 0.1, 0.5, 0.2, and so on. And in this example, we have n equal to 7 and alpha equal to 0.05, which is 5%. The This means that the degree of freedom is 5%, and we have a level of significance of 95%. For this two-tail test, because we have yes or no, because not greater than or less than, so it's a two-tail test. The critical value will be the intersection of the sample where n equal to 7 with here with the level of significance of 95%, which is alpha equal 0.05, so the intersection equal to 2. So this is our critical value. Now we will move here we will start the step 3. Step 3, we will find the test value to compare it with a critical value that we already get it from the previous step. So the step 3 included sub-steps inside it. The first one that we will make table like this. We have already the before values for 7 days and after values for 7 days also. The first column that we will get the values in the difference between XP noted for the values for before and XA noted for the values for after. And we will get the difference in XP minus XA. So we 7 minus 5, here 2 minus 3, 3 minus 4, here 6 minus 3, 5 minus 1, 8 minus 6, and finally 12 minus 4. These values represent the difference in between the XP before and XA after. Then we will take the absolute value for each values. So here the absolute value will be 2, 1, 2, 6 minus 3, 3, 4, 2, and finally 8. Then we will rank. We will rank our results and we will put the sign of the rank in this values. So after ranking the values, we find that the difference column, in the difference column, here are the values and the absolute values like this. We have all the values should be positive values. So this is the value, the steps P and C that we already do in the previous table, and get two columns, the column for the differences values and the other column for the absolute value, and the absolute value for any number except 0. You should take care about this point. It's a positive number. Any difference of 0 should be included. If you have a 0 values, we should ignore it. So the values will be as follows. Number D, we will rank the absolute values that we already have in the previous step, or the step C, from the lowest to the highest. So we have 2, 1, 1, 3, 4, 2, and 8. So we will use 1. If we rank, recall please the ranking step, you will find you have to 1, 1, 2, 3. So we have to choose 2 and 2, 3, 4, and 8. So the number 1 and 1, this take a rank of 1.5 and 1.5. Number 2, we have 2 number take 2 value. So we have 3.5 and 3.5. Number 3, this is be the fifth value, so it will have take 5. Number 4 is the sixth value, so it will take a rank 6. And finally, the value 8 take the rank 7. So we have 7 values with 7 ranks, but we have the values 1 and 1 have 1.5 because it's repeated, and also 2 and 2 take values 3.5 because it's repeated. Given each rank a plus or minus sign according to the sign in the difference column. This means that we will go again to the first column and show what is the sign of the difference and take the rank of each one according to the different column to complete the table here like this. So we already take the values with the absolute value like this, and then make a rank like this, and recall again the signs. This is positive sign and take it positive sign. This is what negative sign, take it negative sign again. This is negative sign, become negative value, and so on. Every value, recall it to the sign of the difference to get the values like this. Number F or step F, find the sum of the positive ranks only. Please concentrate. Find the ranks, the sum of the positive ranks. So we have how many ranks, positive ranks, plus 3.5 and plus 5 plus 6, 3.5 and finally 7. So the total positive rank sum equal to 25 and negative rank sum equal to -3. So we will select the smaller absolute value for the sum. The absolute value for this equal to 25 and the absolute value for 3 equal to 3. And we will select the negative rank sum because it is the smallest absolute value to be our test value. Now the step is very easy, but just you should concentrate and of the signs and the calculations to get the tested value too. So here the tested value was 3, and if you recall step 2, the critical value was 2. We will compare in the next step, we will compare the tested value with the critical value and take the decision. Before taking the decision, we just overview again about the step 3, which have to get the tested value. Again, we have, this is the example, our example. And the first step, we will get the difference in between the before and after, like this. And then we will get the absolute value, take all the positive values. Then we will rank the values. After ranking the values from the lowest to the highest, the one we have 2 ones. So if each one take 1.5 and 2 values have 2, so each one take 3.5. And then rank all the values that not repeated, like this. So then we will make a column that's sign ranked. Sign ranked, which is the sign for the difference. Here, the difference was positive, take it positive. The difference negative, take it negative, and so on. That we have in the ranked signs, we have values positive and values that's negative. So we will sum the positive rank sum together and the negative rank sum together, and we get positive values 25 and the negative rank -3. After adding the positive rank sum and negative rank sum, we will take the absolute value for the negative rank sum. So the absolute value equal to 3 and we have 25. We will take the smallest number to be our test value. This is for the third step to get the test value. Now the step for the decision. We will reject the null hypothesis if the test value is less than or equal the critical value. Recall in step 2 we have a critical value 2, and in step 3 we have the test value equal to 3. And then applying the decision rule, the decision will be not reject the null hypothesis because the test value is greater than the critical value that we obtained from the table, or by other meaning that the calculated value is greater than the tabulated value that we have from the appendix in your book. Now we will summarize the results. There is not enough evidence to support the claim that there is a difference in the number of shipping, hence we will not we will not reject the null hypothesis that is no difference. This is all for the Wilcoxon sign test when the samples are dependent for each other. Now you have an exercise and to practice more about this test and this non-parametric test, a researcher decides to see how effective an pain medication is. We have 8 subjects were asked to determine the severity of their pain by a scale from 1 to 10, with a beginning very minor and 10 p.m. very severe. So you should know how to rank from 1 to 10. Be sure about ranking at this point. Please concentrate. Then each was given the medication, and after 1 hour they were asked again to rate the severity of their pain, if they feel a real pain or not, using the same skill. So this case means that we have a medicine and we want to decide is it effective or not. So we have a 10 that they not take the medicine, and we already have skills from 1 to 10 to each one, and this is before. Then we already have a medicine, and the samples, 8 people are take the medicine, and then after 1 hour they asked about the pain, and the result was this. The answer please this requirement to know the result of your test. Number 1, what is the purpose of the study? And were the samples independent or dependent? Is there any connection between the after and before? Please answer yourself. What are the hypotheses? What is a non-parametric test that should be used or suitable to test your claim? What significance level would you use? Is a significance level is maybe up to the researcher. What is your decision? So again, in number 5 may vary your answer from anyone. It's dependent on how the collection of data is very precise. What is your decision? What parametric test could you use, and would the results be the same? So we have here the answer. Please don't take the answers until you only remember and recall the test and think about it alone. Please think about it alone, then you have the answers here. Verify your answer if you aren't know any one of the